you cannot see the screen, okay? You can remind me, okay? Because sometimes it's my fault, okay? But now in this case, it's not my fault, okay? Okay. Can we continue? Okay. Okay, now we proceed for the time scaling first. And in this case, absolute A is less than 1. Therefore, is equal to 0.5. You expand the signal double. Okay, you can see that at every point, it will be extend double. Okay, 2 times. Okay, and what about the empty data? The empty data, you can, okay, the unavailable data, you can determine them from average. The average from each neighborhood. For example, this point, okay, for this point, x, y at -3, okay, in the left hand equal to 0, right hand equal to 1, the average equal to 1, okay, average equal to 1. This equal to 2, left hand equal to 2, right hand equal to 2, the average of them equal to 2, okay, and so on, okay. The next, okay, after you expand them completely, it means you already determine the time scaling. The next step you determine for reversal. In the graphical point of view, yn equal to x minus n is the mirror image of the original signal xn that is reflected about vertical axis. Clear? Okay, I will show you in the detail. Okay, next one. In this case is, okay, yn equal to x2n. Okay, x2n is mean you determine only time scaling, But in this case, it's different from the previous one. In the graphical point of view, yn equal to xan is the compress or the expand of the original signal xn, depend on absolute A. For absolute A is, okay, in this case, if absolute A is greater than 1, therefore the functions yn is a compressed in time. How to compress them? You can see that the compressed version, okay, we have 2 steps. The first one, you discuss the data first, okay. In this case, okay, due to, okay, A equal to 2, right? If A equal to 2, you only hold or only still keeping the data in the event index. Event index is a 0, 2, 4, -2, -4. You only store this data. For the rest, you discard them or eliminate them. And after that, you compress them. Okay, we have 2 steps for time scaling in this case. Okay, now next one. Okay, yn equal to xn minus 2. xn minus 2 is mean you require to take about the time shifting. In the graphical point of view, yn equal to xn minus n naught is the right shift image of the original signal xn when n naught is greater than 0. And in this form, you can see that the n naught equal to 2. If n naught equal to 2, you shift in the right hand by 2 point. 2 point here. Okay, next one. Okay, x minus n and minus 2. X minus n and minus 2 is mean you take, okay, you require to take the time reversal minus this minus represent for the time reversal and 2 represent for time scaling. Okay, in this case, you must take about the time shifting first and take, oh sorry, not scaling, time shifting. You must take time shifting first and you take reversal in the final step. In the graphical point of view, yn equal to xn minus n naught is the right shifted image of the original signal xn when n naught is greater than 0. N naught is greater, in this case, n naught equal to 2, right? In this form, because the form is already n minus n naught. N naught equal to 2. Okay, if n naught equal to 2, you shift in the right hand by 2 first, okay? And after you shifting them completely, the next step you determine the time reversal. In the graphical point of view, yn equal to xn minus n is the mirror image of the original signal xn that is reflected about the vertical axis. Here. Okay, you can check that the thing that you do is right or wrong, and if wrong, which point is wrong. Okay. Next one, okay, yn equal to x minus n plus 2. Okay, the same as the previous. Okay, it have the time shifting and it have the time reversal. You must take, okay, you must proceed for the time shifting first. In the graphical point of view, yn equal to xn minus n naught is the left shift image of the original signals xn when n naught is less than 0. Okay, in this form, you can see that the formal form of the time shifting n minus n naught. In this case, n plus 2 is mean n naught equal to minus 2. If the n naught is equal to minus 2, it means you shift in the left hand side by 2 first. Okay. And the next step, you proceed for the time reversal. In the graphical point of view, yn equal to nx minus n is the mirror image of the original signal xn, that is the reflected about the vertical axis. Yeah. Okay, minus n is here. You take the reversal in this axis. Okay. Okay. Now for the second question. The second question will be provide you, okay, maybe yeah, given the signal as shown in the following figure, okay, the same signal as the previous, but almost all is have the amplitude transform, but some maybe have both. Okay, for the amplitude transform, you know that amplitude transform we have three transform: the amplitude reversal, amplitude shifting, amplitude scaling. Yeah. Now the first one we have here minus, okay, minus in front of x is represent for amplitude reversal. 3 represent for amplitude scaling. Plus 2 is represent for amplitude shifting. Okay. In the graphical point of views, yt equal to axt is compared or the expansion of the original signal xt in the vertical axis depend on absolute a. For absolute a is greater than 1, the functions yt is expanded in amplitude. Okay, the first one we will expand, we proceed for the amplitude scaling first. Okay, amplitude scaling by 3. Okay, you can see that in this case, due to the axis, okay, due to the slide have the limit space. Okay, therefore we extend about the scaling in the okay vertical axis, okay, instead. Okay, here is change 4 to 3 times is 12, right? It's 12, and change from minus 4 to be minus 12. Okay, you proceed for the amplitude scaling first. The next step, you proceed for amplitude reversal, minus, okay, minus represent for the reversal. In the graphical point of view, yn is the mirror image of the original signal xn, that is reflected about the horizontal axis. We flip respect to horizontal axis. Yeah. Next one, the last step. After you proceed for the amplitude scaling and the amplitude reversal completely, you proceed for amplitude shifting in the final step. For the amplitude shifting, in this case, you shift by 2. It means at every point of the data, you adding by 2, or you shift upper. Okay, in the graphical point of views, yt equal to xt plus b. Okay, and b in this case equal to 2. Okay, is the shifted image of the original signal xt in the vertical direction. Okay, you can see that we shift by 2 at every point. Okay, you know that, okay, the key for this graph representation is the head of them, the dot of them. The dot represent to its value at its point. Okay, use concern to move only the dot of them first, and you redraw, you ring between the dot and the horizontal axis again, redraw them. Yeah, you can see that, you get here. Next one, okay, yt equal to 2x minus t. X minus t, minus represent for time reversal, 2 represent for amplitude scaling. Okay, for time and amplitude transform. Okay, the signal must be processed, must be amplitude transform first, and then time transform later. In the graphical point of view, yt equal to axt is the compress or the expand of the original signal xt in the vertical axis, depend on absolute a. Okay, in this case, absolute a is equal to 2, it means it's greater than 1. Therefore, the functions yt is expand in amplitude. Okay, we will expand the scaling, rescale the, okay, in the vertical axis, okay, from 4 to be 8 double. Okay, scale by 2. Okay, 4 to be x. Okay, and next one we proceed for the time reversal. For the time reversal, in the graphical point of view, yn equal to x minus n is the mirror image of the original signal xn, that is reflected about the vertical axis. You flip respect to vertical axis. Yeah. Now the next one, yn equal to 3xn minus 2. Yt equal to xn minus 2. Okay. In this case, okay, 3 is represent for amplitude scaling, minus 2 represent for time shifting. Okay. For the time and the amplitude transform, the signal must be amplitude transform first and then time transform later. Okay. For the amplitude transform, okay, in this case, in the graphical point of view, the amplitude transform is already in the form of yt equal to axt, is the compression or the expansion of the original signal xt in the vertical axis, depend on absolute A. And in this case, absolute A equal to 3. In this case, for absolute A is greater than 1, the functions yt is expand in the amplitude. Scale by 3, okay? We rescale from 4 to be 12, 3 times, okay, 3 times. Therefore, this point equal to, okay, this point used to be equal to 2, it equal to 6 in this case, 6, okay, and 12. Next one, you proceed for the time shifting. In the time shifting, in the general form of the time shifting, okay, n naught, n minus n naught. Therefore, in this case, n naught equal to 2 is positive, okay. In the graphical point of views, yn equal to xn minus n naught is the right shift image of the original signal xn. For n naught will be greater than 0. You shift in the right hand. Okay, right hand by hand. Okay, it's finished. Okay. Now the next one is about here yn equal to minus xn and plus 3. It means in this case, we this minus represent for amplitude reversal. Plus 3 represent for amplitude shifting. Okay. For this case, you must process for the amplitude reversal first. Okay. In the graphical point of view, yn is the mirror image of the original signal xn, that is the reflected about the horizontal axis. You flipping in the horizontal axis first. Okay. And next one, in the graphical point of views, yt equal to xt plus b is the shifted image of the original signal xt in the vertical direction. Okay, you shifting them in this case, checking that b in this case is plus 3. B equal to 3. Therefore, it's positive. If it's greater than 0, it means you shift every signal up. Okay, up 3 point, 3 point. Okay, 3 point. You can see that we concern only the dot of them. It used to be 0, it will become 3. It used to be 4, it becomes 7. Okay, and you redraw them. Link between the dot and the horizontal axis. Okay. Yeah. Next one. Okay. Yn equal to 2xn minus 2 plus 1. The first 2 is for the amplitude scaling. Okay. Minus 2 represent for the time shifting. Plus 1 represent for amplitude shifting. Okay. For this case, you must proceed for amplitude first. For the time and the amplitude transform, the signal must be amplitude transform first and then time transform later. For the amplitude transform, okay, you must proceed for the amplitude scaling first. In the graphical point of views, yt equal to axt is the compression or the expansion of the original signal xt in the vertical axis. Okay, depend on the absolute A. For absolute A is greater than 1, the functions yt is expand in amplitude. You scaling them by 2, right? Expand the signal or rescaling the vertical signal by 2, change from 4 to be A. Okay, the signal used to be 4 or used to be 2, it become 4. Okay, and if it used to be 4, it become A. Okay, next step we proceed for the you proceed for the amplitude shifting. In the graphical point of view, yt equal to xt plus b is the shifted image of the original signal xt in the vertical direction. Okay, you shift up at every point by 1. Every point by 1. Because the form is already in yt equal to xt plus b, right? Comparing for the functions given by here is equal to b equal to plus 1. Okay. It changed from 0 to be 1. It changed from 7 to be, it changed from, 4 to be 5. Yeah. Redraw them. Okay, I'll redraw them. Okay, next one, yn equal to 2x minus n minus 4. Okay, 2 is represent for amplitude scaling, minus represent for minus in front of n, in the bracket represent for time reversal. Minus 4 is, is represent for amplitude shifting. For the time and the amplitude transform, the signal must be processed, must be amplitude transform first, and then time transform later. And for the time transform, you must process for amplitude scaling first and amplitude shifting later. In the graphical point of view, yt equal to axt and a equal to 2 for this case is the compressed or the expansion of the original signal xt in the vertical axis depend on absolute a. For a equal to 2 is will be greater than 1. Therefore, the function yt is expand in amplitude. You rescale the vertical axis by 2. Okay, change from 4 to be 8. Okay, at every point. Next one, you proceed for in the graphical point of view, yt equal to xt plus b is the shifted image of the original signal xt in the vertical direction. Yeah, shift down. Okay, you can see that in this case, compare for this form, b equal to minus 4. You shift every point down by 4 points. Okay, it used to be 4. This signal used to be 4, shift to be 0. It used to be 0, it shift to be minus 4. Okay, and so on. Redraw them again, give you this signal. Okay, the last one in the graphical point of view, yn equal to x minus n is the mirror image of the original signals xn, that is the reflected about the vertical axis. Yeah, minus n is represent for time reversal. You flip respect to vertical axis. Okay, flip here. The signal in, okay, that you compute that. Okay, the next one, given xn, okay, given xn as shown in here, okay, if the signal is different in here, okay, the question determines time transform for this signal. Okay, the first one is determines the time reversal, yn equal to x minus n. Okay, in the graphical point of view, yn equal to x minus n in the mirror image of the original signal xn, that is the reflected about the vertical axis. Okay, the signal xn in here, x minus n, you flip respect to vertical axis is here. Okay. Next one, you have minus represent for amplitude, represent for the time reversal. Divide by 2 or multiply with 0.5 is mean is for time scaling. Okay, for both steps you must take time scaling first. In the graphical point of views, yn equal to xan is the compression or the expansion of the original signal xn depend on absolute a, and the absolute a in this case equal to 0.5, it will be less than 1. Therefore, the function yn will be expand by 2 times. You can see that we will expand the signal by 2 times. Okay, the rest is will be interpret them. Okay, you interpret the data between that. Okay, after you do that, you will proceed for time reversal. Okay, for the time reversal, in the graphical point of view, yn equal to x minus n is the mirror image of the original signal xn, that is the reflected about the vertical axis. Flip by here. Okay, the next question is yn is equal to x2n. Okay, x2n is the one type of the, okay, it's about one type of the time scaling. Okay, but in this case it's different from the previous. Okay, this time scaling due to, in the graphical point of view, yn equal to xan is the compression or the expansion of the original signal xn depend on absolute a. For absolute A is greater than 1, the functions yn is compressed in time. Okay, you discuss half of the data first that not located in the event index, okay? And after you discard them, you compress them after that, okay? The next one is yn equal to xn minus 2. Xn minus 2 is the time shifting. In the graphical point of view, yn equal to xn minus n naught is the right shift image of the original signal xn for n naught will be greater than 0. In this form, you can see that xn minus n naught. The questions give you xn minus 2 is mean n naught equal to 2. If n not equal to 2, it means it's positive, it's greater than 0. Therefore, the signal will be shifted in the right-hand side 2 point as shown in the slide, okay? In here. Next one, yn equal to x minus n minus 2. Minus n minus 2 is mean here. Okay. Minus n represent for time reversal. Minus 2 represent for time shifting. Okay. We proceed for the time shifting first. In the graphical point of view, yn equal to xn minus n naught is the right shift image of the original signal xn for n naught is greater than 0. And in this case, n naught equal to 2, right? In the form n minus n naught, n minus 2. Okay. Therefore, n naught equal to 2 is positive. Okay. You shift in the right-hand side 2 point. Okay. 2 point. And the next one, you proceed for time reversal. In the graphical point of views, yn equal to x minus n is the mirror image of the original signal xn, that is the reflected about the vertical axis, shifting respect to vertical axis. Okay, the last question for this main question is yn equal to x minus n plus 2. Okay, minus n plus 2 is mean minus okay. Can I break a little bit? Hello? Hello? Anyone
Yes,
can hear
yes,
me?
yeah.
Okay, can I break a little bit drinking? Okay, can we continue? Okay. Yn equal to x minus n plus 2. Okay, minus n is mean, yes. Hello, can you hear me?
Yes, ครับ
Okay. Yn equal to minus n plus 2. Okay, it minus n represent for reversal, plus 2 represent for shifting. We must proceed for shifting first. In the graphical point of views, okay, the general form is already xn minus n naught. In this case, n naught equal to minus 2. If n naught equal to minus 2, you shift in the left-hand side. Okay, in the graphical point of view, yn equal to xn minus n naught and is the left shift image of the original signal xn for n naught will be negative. Okay, next one, shift in the left hand side by 2 and we proceed for the time reversal. The time reversal compute by in the graphical point of view, yn equal to x minus n is the mirror image of the original signal xn, that is the reflected about the vertical axis. Yeah. Okay, the last one. Okay, the last one is here. Okay, for the last question, the signal is here. It's argued for the amplitude and time transform. Okay, we proceed for the first one. Okay, we have minus represent for amplitude reversal, 3 represent for amplitude scaling, and plus 2 represent for amplitude shifting. For the amplitude, we must proceed for amplitude scaling first in the graphical point of view. Yn equal to xn. Okay. Sorry for that. I changing a little bit one for n. Okay. In the graphical point of view, so kyn equal to axn is the compression or the expansion of the original signal xn in the vertical axis, depend on absolute A. In this case, A equal to 3, therefore the signal will be extend 3 times, okay? Or in this case, we will rescale the signal 3, okay? 3 times from 4 to B12, okay? 4 to B12, yeah. Next one, we proceed for the amplitude reversal. In the graphical point of view, Yn is the mirror image of the original signal Xn, that is the reflected about the horizontal axis. Okay, we flip respect to horizontal axis. Okay, you can see that. We proceed for that. And the last one, we proceed for the amplitude shifting. In the graphical point of views, Yn equal to xn plus b is the shifted image of the original signal xn, that is in the vertical direction. In this case, b equal to 2. Okay, b equal to 2, you shift every point up by 2. Okay, 2 points, and you redraw them. The result is here. Okay, next one, Yn equal to 2x minus n. Yn equal to 2xn minus n is mean, okay, 2 represent for amplitude scaling, minus n represent for time reversal. For the time and the amplitude transform, the signal must be amplitude transform first and then time transform later. For the amplitude transform, in this case, in the graphical point of view, y ends yt, okay? I think it's a little bit wrong. I will fix this slide a little bit one. Wait a minute. Okay, already finished. Okay, we proceed for the amplitude scaling first. In the graphical point of view, Yn equal to xan is the compression or the expansion of the original signal xn in the vertical axis, depend on absolute A. For absolute A is greater than 1, therefore the functions Yn is expanded in amplitude. Okay, you can see that we change the scaling from 4 to BA. We amplify them 2 times. Okay, and the next step we take the time reversal. For the time reversal is in the graphical point of view. Its time reversal is the mirror image of the original signal xn, that is the reflected about the vertical axis, flip respect to vertical axis. Okay, next one is here Yn equal to 3xn minus 2. Okay, for the time and amplitude transform, the signal must be processed for the amplitude first and take the time later. 3 is for amplitude scaling, minus 2 is for time shifting. Okay, again, a little bit again, wait a minute. Okay, therefore, we have both time and amplitude transform. You must proceed for the amplitude first. Okay, for the amplitude, you take amplitude scaling by 3. Okay, scaling by 3 is mean you expand the vertical axis 3 times. Okay, in the graphical point of view, Yn equal to Axn is the compression or the expansion of the original signal Xn in the vertical axis depend on absolute A. For absolute A is greater than 1, then the function's yn is expand in amplitude. Expand in amplitude. Okay, here. And the next one, okay, we proceed for time shifting. In the time shifting in this case, okay, in the graphical point of views, the time shifting is shift to the right shift image of the original signal xn for n naught will be greater than 0 or n naught positive. In the form n minus n naught, you can see that n naught equal to 2, right? N naught equal to 2, therefore it shift in the right hand side here. Okay. Next one, okay. The first question, minus represent for amplitude reversal, plus 3 represent for amplitude scale shifting. Okay. We must proceed for, okay, we must proceed for amplitude reversal first. Okay. In the graphical point of view, yn is the mirror image of the original signal xn, that is the reflected about the horizontal axis. Flip respect to horizontal axis first, and you shifting by amplitude shifting later. In the graphical point of view, yn equal to xt, xn, not xt. Okay. Okay. Yeah, you proceed for the amplitude reversal first, okay, and you proceed for amplitude shifting. In the graphical point of view, yn equal to xn plus b, and b in this case equal to 3 is positive, right? If it's positive, it means it shift every point up by 3, okay, every point up by 3. You get here and you redraw it. Okay, the next one, yn equal to 2 xn minus 2 plus 1, okay. For the time and amplitude transform, the signal must be amplitude transform first and then time transform later. Okay, this is the same. Wait a minute. Redraw is change the slide variable to be t to be n first. Okay, and yeah. Okay, 2 is represent for amplitude scaling, minus 2 represent for time shifting, and plus 2 plus 1 represent for amplitude shifting. Okay, we take amplitude first, and for the amplitude we take amplitude scaling first. Okay, amplitude scaling in this case, in the graphical point of view, yn equal to axn is the complete or the expansion of the original signal xn in the vertical axis depend on absolute A. In this case, A equal to 2. Therefore, the functions yn will hello, can you hear me?
Yes.
Yes.
Okay, due to my internet interrupt a little bit one. Okay, can we go to the almost the last question? Okay, yeah. Yn equal to 2xn minus 2 plus 1. Okay, we proceed for amplitude scaling first. You scale by 2. Okay, scale by 2. You expand amplitude by 2 times first, okay, to be x is here, okay. And next one, you shifting them by +1. You shift every point, add with 1, every point by 1, okay. Redraw them, okay. Last step, you take shift time transform. For the time transform, you take only time shifting. Time shifting is already in the term of n minus n naught. Okay, n minus n naught is mean if n naught equal to 2, okay, in this case, n naught equal to 2, you shift in the right hand side. For the graphical point of view, yn equal to xn minus n naught is the right shift image of the original signal xn for n naught will be greater than 0. Yeah. Okay, you shift by here. Now for the last question, okay, 2 yn equal to 2xn minus n plus minus 4, okay. 2 represent for amplitude scaling, okay. Minus 4 represent for amplitude shifting, and minus 1 represent for time reversal, okay. For the time and the amplitude transform, the signal must be amplitude transform and then time transform later. In the graphical point of view, yn equal to axn is the compression or the expansion of the original signal xn, not xt. Change a little bit one. Wait a minute. Okay. Sorry, a little bit. Okay. Yeah. Change the resource. In the graphical point of view, okay, for the amplitude scaling, you scale by, in this case, a equal to 2. Okay. Yn equal to axn, where can be compressed or the expand of the original signal xn in the vertical axis depend on absolute a. In this case, absolute a equal to 2. Therefore, the functions yn will be expand in amplitude. We expand by double, okay. Change from 4 to be 8, okay. Yeah. Next one, you proceed for another amplitude transform, amplitude shifting, okay. In the graphical point of view, yn equal to xn plus b, okay, plus b in this case, b equal to minus 4, right? Therefore, you shifted the image of the original in the vertical direction, shift down, okay. Bring the signal at every point down by 4, okay. You can see that, and you redraw them. The last step, you proceed for the time transform, the time reversal. In the graphical point of view, yn equal to x minus n is the mirror image of the original signal xn, that is the reflected about the vertical axis. Okay. Any question? I think I provide you almost a complete solution for the homeworks that you take. Hello, can you hear me? Any question?
No question, sir.
Okay, now we go to the next part. You can see my slide.
Yes, sir.
Okay. Okay, we've already finished the first 3 topics. Now we go to another 3 topics. The singularity function, the discrete time system, and the property of the system. Okay. The singularity function in this case, it have 2 functions, the same as the continuous. Okay. We have the unit step and we have the impulse. Okay. But in the discrete manner. The concise mathematical definition of the discrete time unit step function can define here un equal to 1 for n greater than or equal to 0 is here, okay, and equal to 0 for n less than 0, okay. In general, a discontinuity or the switch action often takes place at any instant that is defined at n equal to n naught, okay. In this case, if it's okay, this function will be, you can see that is a unit step function. This is the general form of the unit step function. You can see that this form is already in the time shifting, right? it will be shift, okay, depend on the n naught. If n naught is positive, it will be shift to the right hand side, okay. In this case, if n naught equal to 2, the function will be start at 2 here, okay, shift to 2. Okay, another one singularity function is the unit impulse function. The cosine mathematical definition of the discrete time unit impulse function or unit sampling functions, okay, will be defined by here, okay, 1 at n equal to 0 and 0 for the rest, okay, this form. Although the unit impulse function is not really exist in the nature, it has so many mathematical analysis and the application in the engineering. In general, a discontinuities often takes place at any instant that is defined by n naught. You can see that the general form of them is the delta n minus n naught. It means it's a time shifting version of the original one. Depend on the n naught. If n naught equal to 2, okay, you shift in the right hand by 2. Okay. Okay, this for the unit the singularity function. The next one is the discrete time system. What about this? Okay, every point is here. The first 5 topics, the first 4 topic is the signal. Okay, the discrete time signal. Now another last 2 we will consider for the discrete time system. Okay, almost all system in the digital world figuratively modeled by the discrete time system. Okay, the system is a process for which cause and the effects relation exists. The cause is the input, the effect is the output, and the relationship between the input and the output is the mathematically expressed or is the model as the equation. In general, the system can be represented by a block diagram as shown in this figure. Okay, xn feed to the system. Okay, it have the process by t. Okay, the output equal to the t xn, where xn is the input, yn is the output, and the system process is the t, where t is the transformation, the system transformation. Can be represented by the different equation for the discrete one. Okay, now the interconnection of the system. Okay, if the system is so big and so complicated, you can model them by a small block diagram connect together. In the graphical point of view, the normal system is here, the system, okay, you have the single input feed to the system, output equal to the transformation of the input. The transformation is mean it can be, okay, amplifier, okay, or can be any subject, okay. In the mathematics model, we classify the transformation of the signal into 3 operators. The multiplied by the constant or like the amplifier, okay, we call them proportional. The second one is, okay, you integrate them or you differentiate them, okay, called the PID. I is the integration, D is the differentiation. Therefore, the normal block process, okay, of the system is a PID. The next one, the summing junction, okay. The summing junction, if you have more than one input, okay, 1, 2, or 3 input, okay, you adding together, give you here, okay, the output will be here. The product function, the product junction is here, okay. The product junctions, input and output, okay. You multiply them, input x and x1 and x2 is multiplied, output equal to the multiplication between x1 and x2, okay. For the parallel process, if you have 2 process that connect in the parallel structure, okay, the output equal to the adding between the each output of them, okay, and process transform them, okay. You have input feed to the 2 block, okay, T1 and T2 in the parallel, and the output of Y1 and Y2 you will adding them in the later. The overall system function will be equal to here. And for the series connection or the cascade connection is the same manner. You send X1 to the system 1 first and send the result to the system 2, okay. Therefore, the overall system function is the system 2 and system 1 together, okay. Now, in order to demonstrate what about the behavior of them, okay, determines the output yn as the function of the input and the system transformation of the following figure. You have one input split into 2, okay. One is feed to the process 1, another feed to the process 2. Provide you y1 and the y2. okay, and the result will be y1, y3 equal to the summing between y1 and y2, and you send y3 to the process 3 to generate y4. The y4 result will be adding with y2 and give you the overall result. Therefore, in this case, okay, you can model them here, okay, y3 in this form equal to y1 plus y2, y1 plus y2. You can express y1 in the term of x1 and the process 1 and the process 2 right here. y3 equal to t1x plus t2x. Okay, next one, y. Okay, y4 equal to the process 3 of the y3 is here. You substitute y3 equal to this form. Okay, give you here. Okay, and overall y, the overall outputs y equal to y4 plus y2, y4 plus y2. Okay, you can ask, okay, for y, okay, for y4 is equal to here t3, okay, t1 x4 xn plus t2 xn. Okay, add with y2 is very simple, 1 by 2 equal to x t2 of xn. Okay, for another special block diagram of the system is called the feedback control system. The feedback control system is a very important system connected that the frequency is used in the automatic control. The automatic control is mean the control without the human intervention. Okay, the block diagram of the basics this feedback control system is shown in this figure. Okay, you have the input and you compare with, okay, to the sums data. Okay, the error between the thing that you would like to set and the real input is sent to the controller, and the controller drive the control to the plant. Okay, process that. Okay, the plant is the physical system that is controlled, and the controller is the physical system that inserts by the designing engineering in order to keep the total system certain design the characteristic. Okay, I think the senior project, almost all senior project that you decide about the embedded system frequently use this block diagram. Okay, the thing that you set, or for example, the temperature, checking from the current temperature and the temperature that you set, is it meet or not? If it meet, okay, the controller will be stopped, and but if it not equal, the controller will still process until the temperature reach to the desirable point. The sensor, due to the current today, I think the controller and the sensor is already embedded together. Well, therefore, it's very cheap one, and it every more several type of the sensor is. Okay, the thermal sensor, the vibration sensor, the lighting sensor, include the camera and so on. The sensor is the physical system that measure the signal to be controlled. Okay, and the overall system function, you write X in the term of, okay, you write E, the error in the term of X, and in the term of, okay, the process of the three trees. Yeah, substitute them, give you the feedback structure here. For the general feedback system case, the system output is mathematically expressed as the function of the both system input and the system output here. The last one, we will go fast. The last one is the property of the system. These sections define the property or the characteristic of the discrete time system, like the continuous time. The property defined can be used to test mathematically the discrete time system in order to determine its property. Okay, if we let X to be the input, Y is the output of the system. The notation in this equation state that the notation is called Xn produce Yn, and it can be represented as the following block diagram. Yeah, you feed, okay, Xn to the block diagram generates the outputs Yn. Okay, this section will have up to 6 properties: the memory, causal, invertibility, stable, time invariant, and the linearity. The key is you must know how to prove them. Okay, the idea of the memory is the same as the continuous time. Okay, it's memory or it's memoryless. Okay, it's invertible or it's non-invertible. Okay, is have the, okay, non-invertible. Next one is a causal or non-causal system. Okay, what about the causal system? Okay, you can check that from the continuous time or from the book that you have. Okay, the stable. Okay, If the input is stable, output is stable or not. Okay, you can check in the mathematics formula. Next one is about the time invariant. You process them first and ship them later, equal to the ship them first and process them later or not. If it equal, it means that system is the time invariant, unless it's called time varying. Okay. And the last one is here, okay, the linearity. If the system is satisfy the principle of superposition of the additivity and the homogeneity property, then the system is linear. We satisfy the principle of superposition if the input and the output will be defined by here. If you feed input X, give you output Y. If you feed input X2, output Y2. If you feed X1 and X2 in the same time, output equal to Y1 plus Y2. This relationship, we call them the principle of superposition to prove for the linear system. Okay. Okay, let's do the question in the slide. Can you see it? Hello? Anyone can hear me?
We can hear ครับ
เห็นนะ let's do it quickly. Captures the question in 5, 4, 3, 2, 1. I give you 15 minutes, okay? And we will provide your solution. I will go to drink a little bit. Okay, I'm here. If you have any question, you can ask me. Hello? Anyone finish yet? Oh. Anyone can hear me?
ครับ
Oh, I will check your attendance now by identify yourself. Open the camera now. Okay. ธีรวิทย์นี่ไม่เห็นหน้าเลยเว้ยมันส่องกระจกส่องอวกาศได้ไงวะชินอารมณ์เป็นไง
สบายดีครับ
สบายใจแล้วนี่นิกมาเข้ารอบแล้วไม่ใช่เหรอ
ครับ
สาหัสอยู่แต่ก็เข้ารอบแล้ว ไม่ต้องลุ้นเหมือน OG เสร็จยังรัชตะวันเป็นไงบ้างพัทรนันท์ล่ะเป็นไงบ้างทำเสร็จยัง
ยังไม่เสร็จค่ะ
I will give you another 5 minutes and I will provide your solution okay ชนทิชาเป็นไงบ้างเสร็จยัง
ยังค่ะ
เมื่อกี้เธอว่าอะไรนะกันนี่ฮะ Oh. Okay, some of your friend is already finished. Okay, give you another 1 minute. Okay, and provide your solution. Okay. Okay, we don't have a time. Okay, therefore I will provide you solution first. For now, can you hear me? Hello, can you hear me?
Yes, sir.
Okay, can you see my slide?
Yes.
Okay. Okay, the question is here. Okay, you must check for the SIG property. In fact, this property is the same testing in the continuous time, only for the discrete time. Okay, the first one, the system is memory or not. You can check that. If it has some time shifting in here, it means it memory, and it's already have the time shifting, right? Therefore, the system is memory because the system outputs yn is a function of the system inputs at other present of time xn. It's not depend yn not depend only on xn, but depend on xn minus n naught. Okay, when n naught may be positive or negative. Okay, next one is the system is invertible. Okay, because the distinct system inputs xn produce the distinct system output yn too. Okay, you can prove that. Okay, next one is a causal or not. In this case, is non-causal. Why? Because okay, it will be causal in the case that okay, if you shifting them and n naught is positive. But in this case, n naught is negative, right? Therefore, n plus 3. Okay, if n plus 3, okay, is n naught is okay, it's depend on the future. Okay, it's depend on the future. Okay, in this case. Okay, next one, the system is stable or not. BIBO stable or not. In this case, it's stable. Why? Okay, the system is BIBO stable because the system outputs bound for any bound of the system input depend on as following proof here. If the input, if the maximum of the input is M, you know that the output is only 3 times of the input, 3 times of the maximum of the input. Okay, if the input is M, the peak of them is M, the output is 3M. If M is finite, 3M is still finite. Therefore, it means the output is still stable too. Okay, another two is okay the time invariant proving. You checking first the system is okay, you process them first. Okay, if you process them, give you 3xn it's here from this, and you delay them after that. If you delay them, okay, minus everything by n naught. Okay, or if you delay them first, okay, you delay them. Okay, you can see that if you delay them xn minus here, okay, and you process them, okay, you can see that if you process them, okay, you push n, replace n by n minus n naught. Okay, the thing that you get is here. You can see that, okay, when you process them and ship them is not equal to delay them and process them later. Therefore, in this case, the system is time varying. The system is time varying because the system input xn minus n naught, that is the time shifting, does not produce the system outputs yn minus n naught, that is the same time shifting. The last one is the linearity or not. Okay, if you feed x1, y1 equal to 3, x1 3n plus 3. Okay, if you feed x2, give you here. Okay, if you feed x1 plus x2 and you multiply a1 and a2 in here, you get here. And after that, you can reorganize them, okay, and give you a1 y1 plus with a2 y2. This means this thing is already linear. Okay, therefore it's a linearity. Okay, this thing is true. Okay, you can prove that the system is linear because the system satisfies the principle of superposition of the additivity and homogeneity. Okay. Okay, next one. Okay, I give you 3 questions. Okay, can you see in the meeting chat? Hello, can you see it?
Yes.
Okay, I give you 3. Okay, and the next time I will provide you solution. Not now, not now. The time is up today. Okay. Any question? Okay, if you don't have any question, okay, good luck. See you next time.
อาจารย์ครับ for ข้อ3อะครับตรง yn เท่ากับ 3x วงเล็บวงเล็บ 3n บวก 3อะครับตรงเนี้ยที่เราบอกว่าเป็น non causal เพราะว่ามันเหมือนกับมันมีสมการเพื่อรอ input จาก user ใช่ไหมครับแล้วถ้าสมมุติว่าผมมี 3x ลบ 3อะครับอันนี้คือเป็น non causal เหมือนกันใช่ไหมครับเพราะว่ามันก็รอ input จาก user เหมือนกัน
3x ถ้าเป็นลบ 3เนี่ยมันจะเป็น causal เพราะมันเป็นค่าในอดีต
อ๋อแต่ถ้าโอเคครับอาจารย์
นึกออกใช่ไหมคือระบบ causal เนี่ยถ้าพูดในแง่ physical meaning มันจะหมายถึงว่าระบบเนี่ยที่ขึ้นอยู่กับ input ที่เป็น input ในปัจจุบันหรือ input ในอดีตซึ่งมันเป็นไปได้ทางฟิสิกส์นึกออกใช่ไหมอย่างเช่นมันอาจจะเก็บค่าคุณต้องเคาะก่อนหน้านี้3ครั้งก่อน3นาทีก่อนหน้านี้คุณเคาะทีหนึ่งแล้วคุณก็มาเคาะตอนนี้อีกทีหนึ่งมันเอาค่าใน3นาทีก่อนหน้านี้กับปัจจุบันมารวมกันถามว่าเป็นไปได้ไหมเป็นไปได้ค่อย generate output ตอนนี้นึกออกใช่ไหมแต่ว่าถ้ามันบวกมันแปลว่าอะไรมันต้องรอ output ในอนาคตมันเป็นไปได้หรือเปล่าที่คุณจะสร้างระบบขึ้นมาที่จะ generate output เราตอนเนี้ยแต่คุณต้องเอาค่าวันพรุ่งนี้มาใช้อ่ะ
ครับเป็นไปไม่ได้ครับ
เพราะฉะนั้นเนี่ยในแง่ของเวลาสร้างระบบขึ้นมาเนี่ยระบบต้องเป็น causal อย่างเดียวถูกไหมเพราะมันเป็นไปไม่ได้ที่จะขึ้นอยู่กับ data ในอนาคตเพราะ data ในอนาคตมันไม่สามารถใช้ได้จริงอย่างเช่นคุณอาจจะมองไม่ชัดแต่เอาง่ายๆอย่างเช่นสมมุติว่าคุณใช้อย่างเช่นคุณเปิดระบบแอร์ขึ้นมานึกออกใช่ไหมแอร์คุณขึ้นมาเนี่ยคุณอาจจะมีตัว thermal sensor วัดอุณหภูมินึกออกใช่ไหม thermal sensor เนี่ยมันอาจจะดีเลย์หน่อยมันอาจจะไม่ได้ปุ๊บแล้วได้เลยนึกออกใช่ไหมมันอาจจะสักครึ่งนาที detect ครึ่งนาทีก่อนนึกออกใช่ไหมแล้วค่อย process อย่างเช่นอุณหภูมิมันจะปรับอุณหภูมิตอนเนี้ยสมมุติอีก1นาทีมันจะปรับอุณหภูมิตรงนี้มันจะเช็คอุณหภูมิก่อนหน้านี้1นาทีก่อนแล้วก็เอาอุณหภูมิ1นาทีก่อนหน้านี้มาปรับเช็คของมัน ก็โอเคก็ make sense แต่ถ้ามันจะดีที่สุดคือควรจะปรับปัจจุบันถูกไหมแต่ว่าถ้าระบบมันช้ามันก็ดีเลย์ถูกไหมแต่มันจะเป็นไปไม่ได้เลยถ้ามันบอกว่าจะใช้อุณหภูมิอีก5 นาทีหลังจากนี้กูจะปรับตอนนี้แล้วจะรออุณหภูมิ5 นาทีก่อนมันจะวัดอุณหภูมิยังไงมันต้องเอาโทโมตัวนี้ไปเข้าเครื่องทำแมชชีนเนี่ยนึกออกใช่ไหมเพราะนั้นระบบคอร์ซอลเนี่ยมันเลยสำคัญเพราะว่าจะสร้างระบบจริงๆขึ้นมาในโลกต้องเป็นคอร์ซอลอย่างเดียวมีไหมในแง่แมทโมเดลเนี่ยมันมีคนพรูฟว่าถ้าเป็นนอนคอร์ซอลมันดีนู่นนี่แต่ในแง่ฟิสิกส์บอกทำไม่ได้ไม่มีใครสร้างเครื่องทำแมชชีนได้คุณอาจจะเห็นในเรื่องของหนังไซไฟแต่โลกจริงคุณเคยเห็นไหมถ้าคุณสามารถหาได้ผมไม่ต้องขอข้อมูลอะไรขอลอตเตอรี่อีก15 วันก่อนหน้านี้หลังจากเนี้ยคุณบอกเบอร์ลอตเตอรี่หวยให้ผมได้เนี่ยผมก็รวยแล้วล่ะถูกไหม
ครับ
นึกออกใช่ไหมคือมันเป็นทางด้านฟิสิกส์อย่างเงี้ยหรือว่าง่ายๆอย่างเช่นตัวที่เห็นชัดที่สุดในแง่ของฟิสิกส์ก็คือตัวเก็บประจุตัวเก็บประจุเนี่ยตัวเก็บประจุยังไง IC เท่ากับ C dV dt ถูกไหมเพราะฉะนั้นถ้าคุณจะหา V เนี่ยคุณต้องอินดิเกต I ถูกป่ะคำว่าอินดิเกต I เนี่ยคุณอินดิเกตตั้งแต่ไหนอินดิเกตตั้งแต่ในอดีตจนถึงปัจจุบันก็คือประจุมึงเก็บไว้เท่าไหร่ก็ชาร์จไว้เท่าไหร่เหมือนกับค่าในแบตเตอรี่คุณเนี่ยคุณดึงแบตเตอรี่คุณมาตอนนี้จากเครื่องชาร์จเนี่ยค่าของมันเนี่ยไม่ได้ขึ้นอยู่กับที่คุณชาร์จตอนนี้อย่างเดียวถูกไหมมันต้องขึ้นอยู่ว่าในอดีตมันชาร์จมากี่นาทีแล้วถูกไหมเพราะฉะนั้นแบตเตอรี่บอกว่าได้ 75% มันไม่ได้บอกว่าวินาทีที่คุณดึงมามันได้75ไม่ใช่คุณอาจจะชาร์จมา20 นาทีแล้วมันถึงจะได้ค่อยๆขึ้นมาชาร์จที่อยู่ในนี้มันเกิดจากการสะสมค่าในอดีตขึ้นมาเรื่อยๆนึกออกใช่ไหมแต่มันเป็นไปไม่ได้เลยที่ไอตัวชาร์จเนี่ยบอกมึงดึงมาตอนนี้มันชาร์จตอนนี้กับอนาคตมาด้วยแบบไม่ได้มันไม่มีเซนส์ในแง่ engineering ว่าเรามาวิเคราะห์ในแง่ของ map model โอเคไหมว่าทำไมต้องมาพิจารณาเป็น causal ด้วยอย่าง memory จะใช้ก็คือในกรณีที่ระบบมี buffer ถูกไหมถึงจะเป็น causal ถึงจะเป็น memory ได้ถ้าไม่มี memory ไม่มี buffer ขึ้นมามันจะเก็บค่าในอดีตยังไงค่ามาปั๊บเอาง่ายอย่างเครื่องขยายเสียงที่ผมใช้ในห้องสอนอย่างเงี้ยผมพูดตอนนี้มันก็ต้องออกตอนนี้เลยถูกป่ะผมพูดแล้วมันมีเก็บไว้ก่อนไหมแล้วค่อยมาดีเลย์แต่ถามว่าทำได้ไหมได้ถ้าคุณมีบัฟเฟอร์ถูกไหมมันก็จะสร้างเสียงเป็นเอ็กโคได้ถูกไหมเป็นดีเลย์และเอ็กโคได้เห็นไหมแต่ถามว่าจะทำไปทำไมโอเคถ้าจะอัดเสียงผมอย่างอัดในวิดีโอเนี่ยไม่เป็นไรละอัดไปเลยยาวๆจะเอามาเล่นเมื่อไหร่ก็เรื่องก็มาดูซ้ำได้ไม่เป็นไรใช่ไหมเพราะฉะนั้นค่าทั้งหมดในฟิสิกส์เนี่ยก็คือตัวนี้มันจะเป็นเราใช้แมทในการตีความและวิเคราะห์ระบบที่เป็นฟิสิกส์โมเดลว่าระบบมันเป็นยังไงเมมโมรีมันคืออะไรสเตเบิลมันคืออะไรนึกออกใช่ไหมแต่ว่าทั้งนี้ทั้งนั้นเราก็ต้องใช้ความรู้ทางด้านแมทมาพิสูจน์มันเราจะมาบอกว่าชอบระบบตัวนี้มันดีโง่เฮงมันดีไม่ได้เว้ยวิศวะมันต้องพูดด้วยแมท
ครับ
โอเคนะครับ
ขอบคุณครับ
ครับสวัสดีครับ
สวัสดีครับ